Hello everyone! In this video, I want to talk about the relationship between two variables. Because sometimes, when you collect data in your research or project, you need to find out whether the two things are connected or not. And for the example, here I'm going to check the relationship between learning motivation and growth mindset. Well, we already have the data here, and before we start, let's talk about the research question. So, for this research, the question is there any significant correlation between learning motivation and growth mindset? So, basically, I want to find out if students with a higher growth mindset also have a higher learning motivation, or if there is no connection between them. So let's see the hypothesis here. I make two hypotheses. The first one is null hypothesis. There is no significant correlation between learning motivation and growth mindset. And the next one is the alternative hypothesis. There is a significant correlation between learning motivation and growth mindset. So later, after I analyze the data, I will check whether we should accept the null hypothesis or maybe the alternative hypothesis. Well, let's see now. Alright, the first thing we need to do here is copy all the data into SPSS. We copy in the data view here. Alright, we already copied all the data into SPSS and then we go to the variable view here. Well, there is a column called name here. So in this column, we need to change the name of variable into a short one. For the example, the first variable is learning motivation, right? So we need to change it into more shorter. So for the example, like we change it into LM. And then for this one, change it into, well, there is a column. So the column in the label here, we need to write the complete explanation of our variable. So for the first one is, and then the next one, well, so in the measure column here, we need to change it into skill. Because both of learning motivation and growth mindset are numeric scores from the questionnaire, so they are not categories or ranks, but they are real numbers. Well, the next step is we want to analyze here, and then we choose descriptive statistic, and then we click explore. Well, we put both of variable into dependent list. Because we don't have any group here, I leave the factor list empty. And then I click plots and then checks for histogram and also checks for normality plot with this. Then we click continue, then click OK. So let's see the results. Alright, we already have the result of test of normality and I will copy it into Word. Alright, so this is the result. You can see the significant values here. If the significant value is more than 0.05, it means the data is normality distributed. And here, for learning motivation, the value or significant value here is 0.200. And for this Shapiro-Wilk test, the significant value is 0.980. So this, all right. So both are this is more than 0.05, right? So that can be, we can be say that the data is normality distributed. And then from the growth mindset, the Kolmogorov-Smirnov test here, the significant value is 0.008, which is less than a 0.05, right? But because our sample size is under the 200, so we need to focus on the Shapiro-Wilk test here. So the significant value here is 0.126, which is more than 0.05, right? So we can say that the data is also normality distributed. And I also need to check the histogram here. Well, yes, we double click on the histogram picture and then we click show distribution curve. Then we choose normal here and automatic. So here are the results. Well, that you can see here, but variable shows a normal distribution curve, right? Yes, that we expected. So after that, we continue to check the linearity between these two variables. And to do this step, we want to analyze here and then choose a compares main and then click mains. Then we put the first variable into dependent list and then the next one is into independent list. So it doesn't matter guys. Well, then we click option here and then click test for linearity. Then click continue and then we click OK. Alright, sorry guys. So, alright, this is the ANOVA table. Here are the result. Alright, yes, this is the result. And the ANOVA table here, we checks the two things. The first one is the deviation from linearity. So the value here, the significant value, it should be more than 0.05. And here it's a 0.514. So it's no problem. And then we check the linearity value here. The significant value is 0.853. Well, which is actually more than 0.05, right? So this means the data is not a linear. So because it's not linear, we can use Pearson's correlation to this case, but we need to use Spearman's correlation. Well, so before we do that, we need to make a scatter plot here to see the pattern of the relationship, the two variable relationship. Well, to do that, we go into graph here and then we click legacy dialog and then we click scatter or dot. Well, we click the simple scatter and then define. Alright, we put the first variable into y-axis and then the other variable into x-axis. And then we click OK. Alright, so here you can see the dots, right? So the dot here is showing the relationship between the two variables. So it's not a very clear line, right? So to check it, we double click the graph and then we click add add fit line at total and then we choose linear and then apply. Alright, so now you can see the line, right? The line is moved up a little, so it's look like a positive relationship. Yes, this means there is a positive relationship here, but it's a very weak. So we need to copy and then we paste into Word. Alright, as I said before, because the linearity test result is not significant, so we move to the Spearman correlation. Alright, we go back to this and then we did the correlation test. So to do that, we want to analyze here, then choose a correlate, then choose a bivariate this. So we move the variable into this box. Then we chose a correlation coefficient Spearman because as I said before, our data is not linear and we click OK. Alright, so here is the result. Well, you can see the result here. The correlation value here is 0.477. So, and this one is the correlation value is 0.064. So, in this case, we accept the null hypothesis and reject the alternative hypothesis. Well, So the conclusion is the data is normal, but the data is not linear. So we need to use a Spearman correlation, and the research showed that there is no significant relationship between these two variables. Well, I think that's all about my video. Thank you so much for watching, and I hope this explanation is clear and useful for you. Well, see you in the next video.